Perfect. Thank you. Yeah. So again, thank you for the introduction. So yeah, it's great to see that there's such a big desire for consistency. And yeah, standardization may be able to help you out in this regard. So yeah, again, good morning and good afternoon, everybody here from Germany. So yeah, I would like to welcome you to the presentation defining a DIN standard for carbon management. My name is Stefan Kelnberger, and I'm a representative of DIN German Institute for Standardization, so Germany's national standards body. And as a project manager for DIN's research and transfer group, it's my task to advise international DIN external experts on standardization, as well as to assist them in initiating and developing standardization activities based on their expertise or on findings from research projects, for example. So yeah, more about this later. And before I start, maybe just an important disclaimer. I'm unfortunately neither a technical expert in the field of carbon management nor in the field of life cycle assessments, as my background is mechanical engineering. But however, I will be, of course, happy to forward any technical questions about the documents to be presented to the corresponding DIN external experts. All right. Now, yeah, taking a look at today's agenda. First of all, I will provide you with a short introduction on standardization, including information on different categories of standards. After that, I will talk about DIN's efforts to map out standardization and carbon management, as well as to identify future potentials in standardization. I will also inform about DIN Spec documents. So it's a type of standardization document addressing carbon management, which were developed within the research project CO2 Wind Connect, which was funded by Germany's Federal Ministry for Education and Research. In particular, I will also talk about DIN Spec 91508, requirements for the lifecycle assessment of CCU and CCS technologies, which builds on the findings and structure of the TEA and LCA assessment guidelines by the Global CO2 Initiative. All right, yeah. Standardization in everyday life. So yeah, all of us encounter standardization in a broad variety of situations in everyday life, sometimes maybe more, sometimes less consciously. I'd like to give you some examples as a starter. So yeah, the basis of global trade, for example, is the transportation of goods. Cargo ships transport goods across the world's oceans, and on board of these ships are standardized containers, so-called intermodal freight transport containers, which can be used for different types of transport, such as from ships to trains to trucks, without the need to unload and reload their cargo. So this cargo then may include charging cables for electric cars, tools for everyday work. So it's essential for all of these things to commit to certain dimensions and functionalities for applications in order to ensure compatibility and to facilitate trade down the line. And also the benefit of standardization applies to less tangible activities and procedures, for example, to achieve consistency, to meet predefined quality levels, and to ensure safety for everybody, be it either directly or indirectly. So yeah, what exactly is a standard, as it's maybe not tangible at first. So yeah, a standard is defined as a document which is established by consensus and approved by a recognized body that provides for common and repeated use rules, guidelines, or characteristics for activities or the results aimed at the achievement of the optimum degree of order in a given context. Okay, so to break this down, in the end, standards are consensus-based guidelines which aim at providing best practices to harmonize procedures in order to achieve set target outcomes. So the content of standards is not developed by employees of standardization organizations such as DIN, but yeah, it's actually you as external experts who collaboratively work on defining standards on different topics. So our task as standardization organizations is to manage this consensus building process, and we also work on promoting public participation in this process to depict the state of the art as reliably as possible. Now, as the results of this process, standardization documents provide guidance and consistency for users, all while remaining voluntary to use. So standards do not have the status of a law or regulation. However, in some cases, the legislation of a country may decide to refer to existing standards within a law as a sort of publicly acknowledged standard operating procedure, so to say, in a respective field. Now, an important principle of standardization is that there must be no double standardization. So yeah, this means that each topic must only be addressed by one specific standard. This coherence enables interoperability, as users can rest assured that the present standard describes the current state of the art the best way. Also, the consideration of standards fosters safety and quality, both indirectly and directly, as processes are better coordinated and risks can be better recognized as such. All in all, developing and complying with standards facilitates, enables, and promotes global trade. So to benefit of all of these interlocked characteristics of standards, the continuous involvement of experts is quintessential. By contributing knowledge for the benefit of society, participating experts really do make the difference in this process. Okay, so yeah, in the beginning, I already talked about standards and so-called specifications. In general, different types of standardization documents differ primarily regarding the level of consensus required on the y-axis, and also the needed development time on the x-axis. In general, there are three different types of standardization documents, so-called consortial standards, specifications, and standards. So consortial standards are usually developed by a closed body of experts, which clearly separates them from specification and standards, which are developed by an open body of experts. So yeah, this closed body of experts may only consist of members of a singular company or other closed groups. They are not developed under the coordination of a standardization organization, such as DIN, for example. Resulting documents are likely not made available for the general public nor for the competition. And unfortunately, this approach usually results in the cementation of knowledge. Now, taking a look at specification and standards. As you may know, standards exist on the national, European, and international level. They act as a useful tool for the transfer of the recognized state of the art into standardization. They're developed by standards committees that include all interested parties. Now, interested parties represent different parts of society, such as members of the economy, public sector, consumer protection, trade unions, science and research, environmental protection. Yeah, this is to make sure that different views within society are being considered. It usually takes between 18 and 30 months to develop a standard, depending on it being a national, European, or international document, and due to the complete consensus required for standards adoption and publication. Now, this complete consensus, of course, results in the aforementioned high level of trust from users. Also, standards are being reviewed every 5 years to keep them updated and remain valid until being withdrawn. So this happens, for example, when a standard becomes outdated, becomes difficult or ineffective to implement, or when it's no longer meeting safety and quality requirements, for example, that may have changed in the meantime. Now, taking a look at specifications, especially DIN Spec DIN Spec, DIN specification documents on the German level, CWA or CEN workshop agreements on the European level, and IWA or international workshop agreements on the international level. These documents are useful for the transfer of new findings, for example, stemming from research projects into standardization. In contrast to regular standards, these documents are developed by temporary consortia. Also, as there's no complete consensus necessary for the adoption and publication, it usually only takes 10 to 12 months to develop this type of document. Specifications can be seen as the first step towards creating a regular standard, as they can often serve as the basis for a new standard to be developed or to be included into an ongoing standards development process. They are reviewed after 3 years and have a maximum validity of 6 years. So after 6 years, it's assumed that the underlying acute need for standardization was not relevant enough, after all, for the topic to be taken up by a standards committee, so therefore a maximum validity of 6 years. All right, so maybe one more thing. It's also worth mentioning that there are various agreements between national, European, and international standardization organizations in order to avoid double standardization. So again, only standardizing a topic once to not cause any confusion for users. Also, national delegates are being sent by national standard bodies to take part in developments on the European or international level, in order to participate in the development processes. And in general, the results of international and European standardization do have priority over national standardization results. Accordingly, existing or contradicting standards on the national level must be withdrawn when European and/or international standards are being published. Okay, so let's take a look at standardizing carbon management. And also taking a look at the current standardization landscape. So first of all, there are activities on the international and on the European level, which are being coordinated by technical standardization committees. So for example, there are activities or activities are organized within specific working groups or WGs on different topics. For example, on capture, on transportation and storage, cross-cutting issues, and so on. And as you can see in international standardization, of course, there are conveners leading these working groups, organizing them from all different nations. Regarding the European Technical Committee, for example, topics include CO2 streams and quality, pipeline transportation, CO2 accounting, also geological storage. Now, for activities on the national level, there exists the German Mirror Committee on carbon dioxide capture, transport, usage, and storage. So this National Mirror Committee has two main tasks. Firstly, to develop a national opinion, which will be represented by the national delegates within the European and international standards committees when developing and commenting standards that are being developed. Secondly, mirroring the work of European and international standard committees in order to develop uniform standards at national level. So this goes in both direction, participation. Okay, so this German Mirror Committee, for example, is in large parts composed of members of the national standards committees on water practice and also on gas technology. So furthermore, DIN has a department on strategic development, which is responsible for identifying new potentials for future standardization activities. So the tasks include monitoring, changing requirements and frameworks, the derivation of standardization needs, and to give advice towards German standardization committees. So potentials that were recently identified by this departments include, for example, the need for safety standards, so high environmental and safety standards for CO2 infrastructure and CCUS, CCS applications in line with European legislation. Monitoring, reporting, and verification standards, so systems for monitoring emissions, which are regularly updated to ensure transparency and robustness. In this way, adequate accounting can be assured. CO2 accounting itself, as strict accounting rules to determine the CO2 reduction achieved over the life cycle of the resulting products and to price emissions accordingly, and other topics, including direct air capture, safety, environmental standards, marine technology, and carbon farming. Yes, so now specifically taking a look at the need of CO2 accounting. I will present you some DIN specs addressing carbon management and this need specifically. So now, regarding the topic of CO2 accounting, I would like to point out the techno-economic assessment and life cycle assessment guidelines for CO2 utilization by the Global CO2 Initiative. So this document, which is also free to download, addresses the following underlying problems. So the application of LCA and TEA to CCU is not yet comprehensively defined and described. There are difficulties comparing different studies. Also, the validation of underlying data and methods remained problematic. So the scope of the guidelines is to target CCU-specific methodological challenges and to provide recommendations on how to address these challenges in a way that ensures comparability and transparency over the results. Also, it includes detailed worked examples, providing more clarity and on how to apply the guidelines. Also, it's worth mentioning that TEA and LCA remain two separate approaches in the guidelines as it's currently common practice. Further content includes, for example, chapters on the integrated assessment of LCA and TEA, assessment of early stage technologies, how to include the social impact in LCA and TEA, and the guidelines itself is based on the existing ISO 14000 series of standards on LCA, other guidelines, best practices, etc. So yeah, also coming from a layman, it's really worth taking a look at these guidelines. Also, specifically as they were the basis for a DIN Spec document which was developed. So DIN Spec 91508, which I've already mentioned on the requirements for the lifecycle assessment of CCU and CCS technologies. So as mentioned, the guidelines as they were being also built upon the ISO 14000 series, the series sets out requirements for the environmental management systems with little flexibility for different use cases. So yeah, unfortunately, it's not feasible to develop separate LCA standards for every technology. Hence, this DIN Spec document has been developed. So the scope of the DIN Spec is to specify requirements complementary to the ISO 14000 series of family of standards for the life cycle assessment of CO2 capture and utilization and CO2 capture and storage technologies and their applications. Now, this document has recently been published in April of this year. This document also may serve as a template for transnational standardization activities by the new European CEN Technical Committee on CO2 capture, transportation, utilization, and storage and carbon accounting. I also just talked about. It will also promote the establishment of CCU and CCS technologies by promoting their compatibility with LCA recommendations. And as I've mentioned, it was built or is based on the guidelines by the Global CO2 Initiative. Also, the DIN Spec document itself was initiated by GCI's director, Professor Volker Sick, and builds on the findings, as I mentioned. Also, in addition, Professor Sick guided and shared the document's development process. And Dr. Tim Langhorst, who was a co-author of the mentioned guidelines, also assisted as co-chair in the document's development. Now, yeah, the DIN Spec may act as an important cornerstone for further standardization activities to come. And I would like to quote GCI's director, Professor Volker Sick, on this. He said, "I am thrilled that the DIN Spec on LCA for CCUS laid the foundation for further standardization of life cycle assessment. There is a critical demand to ensure globally uniform assessment practices, which are essential for transparent, legitimate, and trustworthy carbon markets. I'm especially excited that the DIN Spec clearly defines the assessment equivalency of durable carbon removal using long-lived products made from CO2 with carbon removal using CCS, such as underground storage of CO2. All right. So regarding the possible next steps for DIN Spec 91508. So yeah. As you can see, the identified standardization need has been developed by the consortium working on DIN Spec 91508. And just a moment. Yeah. And as you can see, there are now different options on how to proceed regarding this standardization. So currently there are talks between the DIN Spec's deputy chair, Dr. Tim Langhorst, the German Mirror Committee on the topic, as well as the European Standardization Committee on how to implement the DIN Spec as a proposed new work item. One way or the other, DIN Spec 91508 might become part of a future standard on the topic as it successfully laid the foundation regarding standardizing this topic. All right, due to the advanced time, I just briefly want to point out that two further DIN specs have been developed as part of CO2 Win Connect. One DIN spec on the subject of photocatalysis, determination of product formation in CO2 reduction, as well as another DIN spec on the utilization of carbon dioxide. So this is a terminology DIN spec describing various terms. Also, both documents can be downloaded for free as well. All right, so yeah, returning to the title of the presentation, there's actually more than a DIN standard on carbon management to define, as there are different aspects of carbon management which can be addressed at the respective level, ensuring a precise and fitting dissemination of the state of the art through various standardization tools I had presented. Standardizing carbon management activities plays an increasingly important role in effectively mitigating climate change, also an important take-home message. And developments in carbon management remain steady, in addition to the continuous monitoring by standardization organizations to identify standardization needs. The sustained initiative and participation by experts, such as from the Global CO2 Initiative, remains an invaluable necessity. As mentioned throughout my presentation, standardization depends on you. So it's your knowledge and commitment that are crucial to creating practical and forward-looking standards. Also, you may get ahead of the game by being part of a dynamic group of professionals proactively involved in the development of standards in your field of expertise. So your participation helps to drive innovation, ensure quality and safety for the benefit of society, all while significantly fostering economic ties and prosperity worldwide. All right, so yeah, please feel free to reach out to the following persons I've listed for more information on the presented and noted topics. And also finally, Christy, Dan, Stephen, thank you for organizing the event and thank you for having me.